Okay, so this is recitation 4. First question. A copper nickel alloy of composition 70% nickel and 30% copper in weight percentages is slowly heated to a temperature of 1400 degrees Celsius. At what temperature does the first liquid phase form? So here's the phase diagram belonging to the copper nickel system. As you all know from your lectures, this is the binary isomorphous system, meaning that in solid state both the elements are completely soluble in each other and they form a uniform homogeneous solid state solution, and there is only a one transition range where both phases, solid and liquid phases, are present, and afterwards only liquid phase is present. So we first find on the phase diagram the composition that we are concerned with. So it's a 70% weight nickel. This is percent weight nickel increasing this way. So this is 70% here. Then at what temperature does the first liquid phase form? So we basically, from this point on, we follow the we increase the temperature and the alloy will follow this path in a straight line. So maybe I can draw this better with a ruler. Okay. So this is the 70% nickel. So this is the path that the alloy will follow upon heating. So the first question was, at what temperature first liquid phase appears? The first liquid phase will appear when the alloy enters the two-phase range, this phase mixture range, and it starts over here around, if you read it from the temperature given in Celsius scale, it's around 1350. The exact value is, I think, 1348. It's given in the answers. So answer to part A, 1348 degrees Celsius. What is the composition of the first formed liquid phase? So now we are going to find the composition of the liquid that has formed here. Now we read that value from the liquidus line. If you're in the two-phase region at a given composition and you find the composition of the phase, not the total composition but of the phase, so we might have in total 40% nickel, for example, but at this temperature, for example at 1250 Celsius, we're in the two-phase region. If you want to know the composition of the solid, which is alpha, we go to solidus line and read it from there. If you want to find the composition of the liquid, we go to liquidus line and read it from there. Same thing applies here. We go to the liquidus line and read the composition from there. And that is around, I mean, when drawing is bad, it seems to be 60% weight nickel, but yeah, it's, let's say, 60% weight nickel. At what temperature does complete melting of the alloy occur? So in order to have complete melting, we must transition into liquid phase. So we continue heating and go up, and somewhere around here complete melting will occur, and if you draw it in a straight line, this will be the temperature that liquid complete melting will occur, and that is around 1380 degrees Celsius. What is the composition of the last solid remaining prior to complete melting? We're going to do the same thing we did previously. We go to this point at the complete melting stage. So around here, this is the composition of the solid now, and composition of the solid seems to be around 80% weight nickel. So that was question 1. Question 2 is about the same alloy system, copper and nickel. So we go to first, the temperature given to us is 1300 degrees Celsius. So we are here. We are between these points here. How do I know we are between these points? Because weight fraction of the alpha phase and liquid phase is given. The alpha phase fraction is 0.6, meaning 60% of the solution is alpha solid, and remaining 40% is liquid. So first you must go to the phase diagram and read these points. Then, after you have read those points, I'm going to draw an enlarged version here. So at 1300 degrees Celsius, we have liquid here, we have alpha here, alpha plus liquid here. These points correspond to 44% weight nickel and 57% weight nickel. Our composition is unknown and we are asked to calculate that, so we must use lever rule at this stage. So I haven't mentioned this yet. These lines that we draw between these points are called tie lines, and from tie lines we have like lever rule to find composition of each phase. Not composition, relative fraction of each phase. So if you take C minus 44 divided by 57 minus 44, this is 100%, so total of the alloy. This part here, let's call this L, and no, let's call this S, and let's call this L. This part will give you this solid. It is equal to S divided by L plus S. That's equal to 0.6. C minus 44 is equal to 0.6 times 57 minus 44. That turns out to be 7.8. Then the composition is 44 plus 7.8, which is 51.8% weight nickel. So at this composition we have 60% solid and 40% liquid. If you do the inverse, 57 minus C divided by 57 minus 44, that gives you the amount of liquid, and that was 0.4. So if we do the same calculation again, 0.4 times 57 minus 44, this is 13. 13 times 0.4, that's going to be 5.2. 57 minus C, and 57 minus 5.2, yeah, 51.8 weight% nickel. Again, we come to the correct solution. So this is 51.8 weight% nickel.